Hello everyone, in this particular video I'll be talking about solution of transportation problem by using a northwest corner rule. Though I have already posted the videos about Vogel's approximation method and the optimal solution, but this is one of the methods of solving the transportation problem. So the problem right here is, so I am going to continue this particular problem by keep continuing solving this particular problem by three different methods. First, I'll be solving it by northwest corner rule, which is right here I'm going to discuss. Then I'll be solving it out by lowest cost entry method. Then Vogel's approximation method is the third method by which it will be solved. And if somebody wants to understand clearly what is the difference between these three methods, you can follow this one problem along and you can understand why Vogel's approximation method is better. So there are 5 videos in total, and after that I also solved the same particular problem on by using Excel solver tool. So you can follow up all these videos and you can understand different approaches and which approach is better, which is not, you can decide by yourself. So if I look into this particular problem, configuration of this particular problem right here, there are 4 plants, 3 warehouses, and these are the shipping costs per unit from each warehouse or each plant to each warehouse. That means 2 rupees the cost of shipping 1 unit from P1 to W1, 7 is the cost of shipping 1 unit from P1 to W2, and so on. These are the capacities of different plants. P1 can produce only 5 units, P2 can produce for 8 units, P3 can only produce 7 units, and so on. And these are the requirements of different warehouses. So my job here is to means design a transportation problem so that all the demand can be catered by the supply. If I look into this particular problem, all the capacity here, if I sum the capacity 8 plus 5 plus 7 plus 14, that is 34. So the requirement is also 7 plus 9 plus 18 is 34. So if the first thing is, I need to check whether my transportation problem is balanced or not. So if my capacity is equal to requirement, so I will write it capacity is equal to requirement. Then I call it, or you can call it capacity, you can call it as supply, and requirement you can call it as demand. And if these things are equal, then you call the problem as a balanced transportation problem. So the problem is called as a balanced transportation problem. If the supply is not equal to demand, capacity is not equal to requirement, then it is called as an unbalanced transportation problem. So if the problem is unbalanced, we balance it first, then we solve it. So let's talk about this method. This is called as a northwest corner rule. And why it is called as a northwest corner rule? Because you already know that that's how we call it east, west, north, south. The directions are mapped. And we always start with the northwest corner of the particular table. That's why we call it a northwest corner rule. So let's start solving this problem. We always start with this cell, as I said, because it's in the northwest location of the table. So first allocation is going to go here. So if I look into my supply and demand, so plant 1 has a capacity to produce 5 units, while warehouse 1 has a capacity to consume 7 units. Though warehouse has a higher capacity in comparison to the what factory P1 is producing, but I cannot supply more than the capacity, because P1 or plant P1 or factory P1 doesn't have more than 5 units to supply. So it doesn't matter how many units warehouse 1 requires, I cannot supply them. Or other way around, you can think of check the minimum of supply and demand and allocate the minimum of them. So 5 and 7 I see with respect to this particular cell, 5 and 7, what is the minimum out of these two? 5, and I allocate it. So I've given you the logic, also a hit and trial way to do it. So P1, if you look into the plant P1, it was having 5 units, was having a capacity to produce 5 units, and this whole problem is for a particular time period. So this could be a plant for 1 month. That means for 1 month, these are the production capacities of different plants. These are the different consumption capacities of different warehouses. It could be for 1 week, it could be for 1 year, it could be, I don't know, it's just one production cycle, right? So the time frame is a particular or specific time period problem is this, and that's why it is of course a case of a linear programming problem. That means particular course of action. So let's go ahead. So P1 was having 5 units and all are being shipped to market W1, so it has no role to play in my further solution. Now let's see. Now I'll move to the P2. Now if I look into the P2, it has a capacity of 8, But does market W1 has a consumption of requirement of 8 left? No, it is left only with consumption of 2 units, because 5 has already been supplied by P1. Now it only requires 2 more units, which I can easily ship from P2. And I am going to ship 2 units. So this demand of market W1 or warehouse W1 is completely satisfied. Now this is exactly the logic, or you can say that if I cut a row, I move into the column. If I cut a column, then I move into the row. So I cut a column, I'm going to move into the row now. That means from here I moved here, I'm going to move here. Or you can say this way, the logic is that warehouse W1 has no requirement at all, but plant P2 still has 6 units left. So I'm going to check it whether how I can supply it to W2 or not, W2 warehouse. So let's see, P2 now has 6 units balance. Out of it, 2 has already been given to W1. It is left with only 6 units. Now these 6 units, W2 has a capacity to consume 9. I can easily give away 6, isn't it? I can easily give away 6. All 6 can be consumed in W2. Now plant P2 was having 8 units. All of them are supplied. 2 are supplied to P1 and W1, and 6 are supplied to W2. Or technically, if I cut 8 row, I'll move into the column, right? Or you can think this way, that W2 is still left with 3 units demand, is still pending, which P3 has to supply. So I'm going to make my next allocation here. Now I need to check, W2 requires 3 units. Do I have 3 units with P3? Yes, I have. I have actually 7 units. So I can easily ship 3 units from P3 to W2. Now W2 was needing 9 units, all are being shipped, out of which 6 from P2 and 3 from P3, and I am going to cut it off. That means the entire demand of market W2 is being completed, finished, satisfied. Now what I am going to do is, again, if you do not understand the logic, you can move it like I cut the column, now I will move the row. Or you can understand that P3 still has certain units left. How many units left? Answer is 4, right? Out of 7, 3 has been given to W2. Now it is left with 4 units. Now I'm going to send some units from P3 to W3. How many are left with P3? 4. I cannot supply more than 4. Now I need to check whether W3 has a capacity to consume 4. Yes, it does. It actually has a capacity of 18. So all 4 it can consume here. That means P3 was having 7 units, or all are being shipped, some to W2, some to W3. Now, or you can think that I cut a row, now I'll move into the column. This is the last cell. The warehouse W3 still requires 14 more units because it was having a consumption of 18. It requires 4 more units. 4 are already been shipped. P4 also has 14. So it is going to supply all its units to W3. Demand of W3 is satisfied. P4 was having 14, all supply went to demand. Now let's calculate the transportation cost. I'm writing it in a little shortcut, TPT cost. It is going to be 2 times 5, 6 times 2. Sorry, I just written straight away the multiplication. So it is 6 times 2 plus 3 times 2. Then I have 4 times 3, because these are the costs per unit. That means 4 rupees is the cost to ship 1 unit. And how many units I am shipping? 3. So 4 times 3 plus 7 is the cost of shipping 1 unit. And I am shipping 4 units from P3 to W3. And plus 2 times 14. So how much I get? 10, 12, 6, 12, 28, 28. So how much it is? 12, 12, 24, 34, 6, 40, 68, 78, 98, and that goes to rupees 102. So this is the transportation cost, rupees 102, and of course I'm going to write quickly here the solution also one more time. P1 is going to give 5 units to W1, right? P2 is going to give 2 units to W1, and P2 is going to give 6 units to, sorry, it is W2. P3 is going to give 3 units to W2, while 4 units to W3, and P4 is going to give 14 units to W3. So this is actually the plan. Okay, I'm just going to shift a little bit right. This is the plan of transportation, and this is the total transportation cost. Thank you very much.